Hey, what's going on, guys? In this project, we're going to create a particle effect background using the P5.js library. And the initial code for this came from a buddy of mine, Florin Pop, who recently started a YouTube channel. And he does some really cool projects, vanilla JavaScript, React, CSS, and he's doing a video just about every day now. So definitely someone you should subscribe to and follow, and you can learn a lot from. All right, so let's jump in and let's create our project. Okay, so I have a couple files here open. I have my index.html, style CSS, and script.js, and these are all empty. So if you're following along, just create these files. I also have my logo, which I'm going to put on top of the particles, and you can use any image or text or nothing at all if you want. So the HTML is going to be really, really simple. Let's just generate a boilerplate, and we'll just say particles effects, and I'm going to link in my style sheet, which isn't going to have much CSS at all. And then our script, which is going to be script.js. And then in the body, I'm just going to have my image, which is logo PNG. Okay, now we do need to include the P5 library. So if we go to p5js.org, you can download it, or you can just go to get started and you can grab the CDN, which is what I'm going to do. So we'll just copy that and paste that right up here. And now we should be able to use the library. So we can close this up. And in the style sheet, real quick, we're just going to add or take away the margin in the body, I should say, and set overflow to hidden. So we don't want any scroll bars. And then I'm going to set the background to RGB. And I'm going to set it to the same blue that I'm going to set the canvas, the P5 canvas background to, which is 55, 100, and 144. Okay, and then for the image, I just want to position it right in the middle. So I'm going to set it to the width of 40% of the window, and we're going to position it fixed and set it 50% from the top, and then 50% from the left. And then to get it right in the middle, we'll just add a transform, and then we'll translate on the X and Y axis negative 50%. And that should do it. So let's open this up. So I'm gonna use Live Server. So I'm gonna open with Live Server, which is a VS Code extension. You can just open up the HTML file if you want, right on your file system. But you can see I just have my image right in the middle here. We have our blue background. So that's it for the HTML and CSS. We can go ahead and close those up. And now we're just gonna work in our script file. Now with P5, we have two main functions for what we need to do. So one is setup, and one is draw. And these, we don't have to manually call these. I'm just going to show you real quick. If I console log setup in this function and then console log draw in this function, I just want to show you what happens here. So if I open up my console, I'm just going to reload. You can see setup gets called once, and then draw is continuously called, okay, which makes it really easy to do animations and stuff like that. So we don't have to manually call these. Now inside of our setup is where we want to create our canvas. So we have a function called create canvas, and this will take in a height and a width and a height, and I want it to take up the entire window. So I'm going to use the browser's window object that has a property called inner width. Okay, so that'll be the width of the canvas. It'll take up the entire width. And then let's do window dot inner height for the height. And then down here, I'm just going to go ahead and draw a circle for now. So we can use like rect for rectangle. We can draw lines with line. I'm going to go ahead and use circle. And it's going to take in three things in this case. The X position, so let's just move it over 150. We'll do 150 on the y-axis, and the size we'll do 80. So just doing that, you can see that we now have this white circle. And there's all types of functions we can use to change the properties of it. If we want to fill it, we can use fill. And we can put like an RGB value in here. I'm going to put a 0, and that should make it black. And then I just want to show you a couple things that have to do with like events and stuff. This has nothing to do with the particles, but just to give you an idea of some of the stuff that P5 can do. So let's say if, and in here we'll say mouse is pressed. And there's all types of events you can check for, and then we can console log here mouse X, and let's log mouse Y. So this will give us the position of our mouse. And remember, this draw function is continuously called. So if I click, it'll give me the position, and if I hold, it just keeps running. Okay, so if I move around, it'll just keep giving me my mouse position. Now, let's do something kind of interesting and let's get rid of the console log, and let's take this fill right here, and let's move this up into here. And then we'll have an else, and we'll say fill, and we'll make this lighter, like 100. So 0 is black, 100 is going to be like a gray. So now if I save this and we go back and I just go ahead and click my mouse, doesn't matter where, and I'm holding it, you can see now it's black. If I let go, it goes back to gray. Now we can go take it a step further, and the mouse X and mouse Y values that I just showed you, let's actually put those as the position of the circle. So we'll say mouse X and mouse Y, which will obviously make this dynamic. So now if we go back, wherever my mouse goes, it's going to give us that circle. So we're basically kind of like drawing. If I click and hold my mouse, it turns black. So pretty cool stuff. I mean, obviously this isn't very useful, but I think it's pretty neat for the amount of code that we just wrote. Now, this stuff here has nothing to do with the particles, so we're going to get rid of that. I just wanted to show you that real quick. And we're going to go under these functions and create a class for our particles. All right, so we're going to call this particle. And basically, for each particle that we create, we need to instantiate a new particle object from this class. And we're going to have a constructor, which is just a method that will run automatically when we instantiate an object from this class. And it's going to have a couple properties. The first thing we want is the position. And to define a property, we use the this keyword. So we'll say this position, or POS. And we want to create what's called a vector. Okay, vectors it's kind of hard to explain. They're defined as an entity with a magnitude and a direction, and they can be represented on an XY axis. And what gets passed in here is an X and Y component. So what this is going to represent is where on the X-axis we want this particle to be placed and where on the Y-axis. Okay, I'm not going to leave X and Y in here. I'm just doing it for now. So we obviously want this to be random. When we instantiate a new particle, we want it to be placed just randomly in the window. So I'm going to go up to setup just to show you real quick a function that's available to us called random. Actually, let's console log this. Okay, so we're going to console log random and see what that gives us. So it gives us a random decimal, 0 point something. Now, this random function, we can pass in a value, like we can say 100, and then it'll give us a random decimal that'll be, 0 point something up to 100 point or 99 point something. So you can see it's different every time. So this random, we want to use this for our X and Y components. So let's say random there and random here. Now, as far as what we want to pass in here, we want the width, basically the width of the browser, of the window, we want that passed in here. And with P5, we can actually use just width and height. If I console log width up here, you can see we get 1324. If I make this a little smaller, we get 1224. So it'll give us whatever the width. It's like using window.innerWidth. So what we'll do is we'll pass in width for the X-axis, so it'll be a random number up to the width and then a random number up to the height for the Y-axis. That way it'll just get plotted somewhere randomly in the window. Now we also want the size, so let's say this dot size, and we'll set this to 10, and you can make the circles bigger if you want. And then in addition to the constructor, we're going to have a draw method, and this is what's going to actually create each circle. So let's say circle, and for the X, where we want to plot it on the X-axis, it's going to be this dot POS, so this position property, and then the X value. for the y, it'll be this dot POS on the y-axis, and then the size will be this dot size. Okay, and then we're just going to format this a little bit. I'm going to take away the stroke, so no border, and then for the color, let's fill it in, and let's make it white. So we'll do RGB 255. So that'll be white, and then the alpha, not RGB, RGBA. So the alpha is basically the transparency, and we'll do 0.5, so it'll be kind of faded. All right, so what we have here in this class is enough to at least plot it somewhere, give it a position, and then draw it. So let's go up to the top, and let's initialize a variable, so basically a global variable in this file called P, and then in the setup, I'm going to go ahead and set P to a new particle object. And then inside draw, I'm going to call p.draw, because I can call that draw method because this P variable is a particle and we have a draw method inside of that class. So let's save that, and let's go back and reload here, and you can see that there's a particle right here. If I reload again, it's going to be somewhere different, because it's getting plotted randomly, and we didn't see it the first time. It was probably within the white, that's why we couldn't see it. But yeah, so it's just going to get plotted somewhere randomly because of this right here, and it's not going to go outside of the window because we have a max of the width and the height of the window. And if we wanted to create more, we could go ahead and we could do like P2 equals new particle, and then we could do P2 draw, and now you'll see we have two particles. So the next thing I want to do is add movement to our particle before we even get to creating multiple particles with an array and stuff like that. So I'm just going to get rid of this P2. We'll deal with one for now. So for movement, we're going to go down into our class here and create an update method. And we need to create a velocity. So basically, how much is this going to move within a certain time frame? So let's say this dot vel, so for velocity, and we're going to use create vector here as well. Now, as far as the x and y, I'm going to use random again, except I want this to be between a certain range. So here we just said, random up to this number. Here we're going to have two values, which will be a range. And that range is going to be -2 and +2, because negative is going to represent going one way on the x-axis, represent going left, and positive will represent going right. So that'll be the x component. For the y component, we'll do random, and we're going to do the same thing, -2 to 2. So that will be our velocity. And in the update, we're simply going to take our position, so whatever position of the current particle, and we're going to add the velocity, this dot velocity. All right, so let's go up here now, and we have that update, so we want to call that actually right here, so p.update. Now, if we save this, we're going to get movement, but something's going to be wrong. See how it's just kind of drawing a line? The reason for that is we don't have a background to our canvas, so it's showing the past position of the circle. So a simple solution for this is to go into our draw, and let's add a background. And I'm going to use the same RGB values that I have in my CSS for the background, which is this right here. So I'll just grab that and put that right in there. And now I'll save and go back, and there it is. So now you can see our particle's moving, and it's not leaving a trail. It's just moving, and it's going to be random, completely random. So now it's going to go that way, and the reason for that is because it's either going to be positive or negative on the x or y axis, and that's because of this right here. And if you wanted this to be faster, we could do like between -20 Actually, we'll just do it on the x-axis, so it should go really fast this way, but slow up and down. So let's save that and look, and there we go. If I reload, okay, so it goes really fast on the x-axis, but I'm going to change that back. So next thing I want to do is track the edges or detect the edges, because right now it's just going off the screen, and we don't want that. We want it to bounce off the edges. So let's create a new method here. We should probably add some comments here. So let's say update movement by adding velocity, and then down here draw single particle, and then let's say detect edges. So we'll have a function called edges. Whoops, I don't need to put function. I don't know why I did that. So for edges, we just want to detect each side. So let's first do the sides, the x-axis. So if we say if, and if you watched my Canvas API tutorial or crash course that I did like 2 weeks ago, a lot of this is pretty similar. It's just easier to do with this library. So let's say if this dot position dot x is less than 0, so meaning the left side, or if this dot position dot x is greater than the width of the window, then that means it hit either side, and in that case we just want to turn it around basically. So let's say this dot vel dot x, and then we're gonna just multiply it by that times -1. So we're basically just gonna turn it around. So we'll use this shorthand, which is the star or asterisk equals -1, and that should basically make it bounce it off. And then we'll do the same thing on the y-axis. So we'll paste that in. We'll just go ahead and change these to y, except we're going to say if y is if y is greater than height, because this time we're dealing with height. And then we'll take this dot velocity dot y and multiply that by -1, which will turn it around. Now we have to call this, and we're going to call it within update. So we'll call it right here. So let's try that. Let's take a look, and it goes up. It goes out like a little bit, it looks like, but it does bounce right off. Let's see if it bounces off the bottom. Okay, so it's just hitting that limit in the conditional we wrote, and then we're turning it around with the multiplying by -1. So it's bouncing off the sides as well. Okay, good. So I think that now we're ready to actually create multiple particles. So the class here is the same, but the way we initialize it is going to be different. So instead of creating this single variable, let's go ahead and create an array. So we'll say particles, and we'll initialize an array. And then down here, let's get rid of this because we're not going to initialize just one single particle. We're going to have a loop. But actually, before we do the loop, we're going to need to know how many particles do we want to create. So we can say const particles length. Now, we could manually set this if we want, but I want a certain amount of particles created based on the width of the window, so that there's not too many if the window's small, or there's not, so the way that we can do that is let's first round down math.floor, and then let's take the window dot inner width and just divide that by 10, and that will give us a certain amount of particles. In fact, let's console log here, see what that gives us. Whoops, P is not defined. Well, we'll just ignore this, but you can see we get 131. Okay, now if I make this window smaller and I reload, we get 62. So in this case, in this size, it's going to create 62 particles. When it's bigger, it's going to create more. It's going to create 130. And just ignore that P for now. Now to initialize this, instead of just creating a variable, we need a loop, right? Because we need to go through all of the particles in the length. So let's say let I equals 0, and then we'll say as long as I is less than particles length, and then we want to increment by 1. Then we want to take our particles array, and we're going to push onto that a new particle. So in here, we'll initialize a new particle. Okay, so it's going to create a new particle for however many particles are supposed to be created. Now, down here in the draw, we have to mess with this a little bit too, because now we're dealing with an array. So we're going to take the particles array, and we're going to loop through it using for each. Oops. So we'll say for each, and I'm going to put some parentheses here. We're going to use an arrow function. I'll just say for each particle, we'll call it P. And then we also want the index, and we're going to be using that in a little bit. Then an arrow function, and then we'll call p.update, okay, just like we did before, and then p.draw, just like we did before, except we're doing it for every particle in the array instead of just a single one. So if we save that, and now we take a look, we have a bunch of particles, 130, I believe. Okay, and it's going to be based on the window width. Okay, so the last thing to do here is to actually create the connections between them, because right now it's just a bunch of floating circles. And you may want that, but I'll show you how we can also connect these as well. So we're going to create, let's see, we're going to create a new method within the class. So right after edges, let's call this check particles, and it's actually going to take in particles. And let's move this up. So within here, we're going to take the particles that are passed in, which is going to be an array, and we want to loop through. So we're going to use a for each here. We'll say for each particle, we want to get the we want to create a distance using the dist function here. So this takes in, it's going to take in 4 parameters. First is going to be the x property on the position. So this dot position dot x. Next will be this dot position dot y. Next is going to be this particular particle's x position, so dot pos dot x, and then the y position of this particular particle, so pos dot y. Now we want to create a line if it's a certain distance. So we'll say if that distance is less than 120, so basically if they're less than 120 apart, then we'll create a line. So we can use the line function, and this is going to take in the same coordinates, these right here, same arguments. And then I'm just going to add a stroke to the line. So for stroke, let's do RGBA 255. So we're going to do white with an alpha of 0.1. And then that should do it. So we need to call this. So up in our draw, I probably should have called this draw method inside the class something different, because we have this draw function here. But we want to go up here and go under where we called p.draw and call p.check particles. Now we want to pass in the array of particles, but from this one on. So we want to do dot slice, and from whatever this index is. That's why I put this index here. Okay, so let's save that. And there we go. So now we have them connecting. If they're 120 or less, then they're going to have this faded line connecting them, giving it that cool look. Okay, so that's pretty much it. I mean, it's not that difficult. We just created a class. We have a position, a velocity, and a size. We draw the circles. We add the movement with the update method here, adding the velocity. We detect the edges and just turn the circle around or the particle around if it hits the edges. And then we create a line if they're a certain length, a certain distance apart. Okay, and then we just have our array. We initialize each one for the array, and then we call those methods. So that's it, guys. Hopefully you enjoyed this, and I'll see you in the next video.